parent functions. What is a parent function? There's not mother functions and father functions, but there's parent functions, right? Parent functions is where all the functions start from. Does that make sense? All the constants start here. They can move up or down, left or right, whatever, but this is where they start. All the linear functions look like this. They can move up or down, left or right. They could even be slanty, right? They could be steeper or shallower, but they all start right here. This is the beginning of each of the different families of functions, okay? These 12 parent functions are the ones that we're going to study this year, all right? So we're going to start today talking about them. On this very front page is kind of like a synopsis. It's like this is all the parent functions, the name, the equation, and what it looks like. And then when we turn the page, we're going to look at each one of them in more depth. Okay? So this very first one, f of x equals a, what is the function name? Constant. And how did you know it was constant? You remembered? Oh, that's awesome that you remembered. But if you didn't remember, then what? It's on the front, right? Okay? Constant. Constant. Now, I know, how many of you had Miss Adams for Algebra 1? Okay. I know you guys are going to be super smart, because so is she. Okay. Do you remember talking about domain and range? I almost said, did you talk about domain and range? But I know you did, right? Do you remember talking about domain and range? Yes and no. Those are both appropriate answers right now, right? Okay? If you don't remember, do you mind if I remind you? Is that okay? Those of you who do remember, what is domain? X's. And what's range? The Y's. So when we're talking about domain, we're talking about the X's. So I would say to you, how far left does this function go? And then how far right does it go? Also all the way, right? So in Algebra 1, what did you say for your domain? You might have said something like all real numbers. Do you remember that? And you might have used this symbol right here, which means what? All real numbers. Exactly. Okay? And in Algebra 1, that was perfect, right? But in Algebra 2, we're responsible for knowing how to write domain and range in two different ways. Inequality notation and interval notation. I don't expect you to know that right away, but I'm going to start using the vocabulary right now so you can get used to it. Okay? This is inequality notation. Interval notation looks like this. Negative infinity to positive infinity. Because didn't you tell me it went all the way left and all the way right? Now, that being said, that being written and that being said, I have to tell you, there's no such thing as negative infinity. Yeah, so why didn't we just write negative infinity? So it's a notation, right? That's a notation. Infinity is just infinity, right? But negative, when we write negative infinity, we're saying specifically we're talking about to the left. Does that make sense to everyone? Okay? So this is our interval notation for this. All right? Let's talk about the range for a constant. How far down does it go? To 1. And how far up does it go? So just 1. So the y values for this constant is 1. And then interval notation, it looks like this. 1. Now, how are you going to know to use the brackets or the parentheses? Well, that's a good question. Okay? We use the brackets when that number is part of the range. When that number is included, or the domain. Is when that number is included in either domain or range. But I'll tell you this right now, we will always use parentheses when we're talking about infinity. Because it can't be included unless I know where the end of it is. Do you know where the end of infinity is? Yeah, me neither. By definition, we don't know where the end of it is, right? So we're always going to use parentheses when we're talking about domain and range. Now, for this particular graph, I told you It's symmetric to the y-axis, which means if I took it and flipped it over like this, it's right on top of itself, isn't it? Okay. I told you there's no minimum or maximum. Does that make sense? There's not a highest point, there's not a lowest point. And I told you it's not increasing and it's not decreasing. Does that make sense? Because it's just flat, right? So it's not increasing it anywhere, it's not decreasing anywhere. Let's talk about the end behavior for a constant function. The end behavior says before I say that, a lot of times people feel like algebra is like a whole nother language, right? Well, I'm here to tell you that I'm bilingual. I can speak English and I can speak algebra, okay? And I'll be a translator for you, right? But you're gonna start to be bilingual in algebra as well. Is that fair? So here's what this means. When we're talking about the end behavior, here's what this means. As x is going to the left, as the x's are going this way, what's happening to the y's? Where is the y? It's just at 1, right? Doesn't matter how far I go to the left, I'm always going to go up to 1. Now, as x is going to the right, as we're going this way, what's happening to the y's? Still the same. It's going to just go up to 1. Now I need a table, an x-intercept, and a y-intercept. Let's talk about the intercepts first. Where is the x-intercept of this graph right here? What's an x-intercept again? Where it crosses the x-axis. That's perfect. So where does this line cross the x-axis? Well, it doesn't. So we just write 1. There's not 1. So where's the y-intercept? Yes. But I have to be picky, right? It crosses at 1, doesn't it? Doesn't this cross the y-axis at 1? But a y-intercept is the point at which the line crosses the axis, right? What is this point called? 0, 1. Does that make sense? Okay? Now I need to fill in a table. For this particular function, we could really choose any x values we want to figure out the y values. On some of the other ones, we're going to want specific x values because of things, maybe there's a change in direction or something like that, an interesting part of the graph that we want recorded on the table. For this one, it doesn't really matter. So are you okay if I choose -2, -1, 0, 1, and 2? And then what's the y values for these? All of them are 1, right? 1, 1, 1, 1, 1. Okay so far? Any questions on a constant function? Okay, then let's look at this next function. What's this next function called? Y equals x is definitely linear. So how far to the left does this graph go? All the way. And how far to the right does it go? All the way. So, all real numbers. That's our inequality notation. And then I need my interval notation to be -infinity to +infinity. How far down does it go? All the way. And how far up does it go? All the way. So is it okay that our domain and our range are exactly the same? Yeah, absolutely. The symmetry is around the origin, which means I could take this and spin it around and it's right on top of each other, right? There's not a highest point because it keeps going and going and going. There's not going to be a time that it gets the highest it's ever going to be. There's also not a lowest point, so there's not a minimum or a maximum. But let's talk about the intervals of increase and decrease. When we're talking about intervals of increase and decrease, the first thing I want you to write right here is domain. Because when we're talking about intervals of increase and decrease, we're saying on which domain, which part of the domain is increasing, which part of the domain is decreasing. Okay? We're talking about from left to right. I start on the left side of the graph and I move to the right side of the graph. Where is it increasing? If I start here and move to the right, where is the graph increasing? Is this increasing? Is this increasing? Is this increasing? So it's increasing everywhere. So if it's increasing over the whole domain, then I write the domain. Isn't that the domain? So if it's increasing everywhere, where is it decreasing? If it's increasing everywhere, it's decreasing nowhere. That's correct. So it's not decreasing at all. All right. As the x's are moving to the left, as we're going to the left, where's the y going? Here's an example. If I move left 3, where am I going? Down 3. If I'm moving left 10, where am I going? Down 10. Using that same pattern, if I move left 100, where am I going? Down 100. So if I'm moving all the way to negative infinity, where's the y going? Negative infinity. Absolutely. As we're going to the left, the graph is going down. That's what this is saying, right? Okay? So as I'm moving to the right, where is the graph going? Up to where? Yeah, infinity. Very good. Does that make sense? Please do not judge my infinities. They're kind of wonky sometimes. I'm not judging yours. Don't judge mine. Okay, let's talk about x-intercept and y-intercept. What is the x-intercept? Where does this graph cross the x-axis? 0, 0. Okay. Where is the y-intercept of this graph? Wait, the same place? I can have the same x-intercept as the y-intercept? When it's the origin, I can, right? Okay, that's okay, isn't it? What x values do we want for our table of this? Is there any changes in the middle of this? No? So let's go ahead and do the same as we did last time. If x is negative 2, what is y? Negative 2? Because y equals x, right? So if x is negative 1, what's y? If x is 0, and 1, and 2. Now, sometimes the confusing part is it doesn't say y, it says f of x. What do you remember about f of x? It's the same as y. For us, right, in Algebra 2, f of x and y are the same. Other maths, it's iffy, right? But for us in Algebra 2, function notation means f of x is the same as y. Is that fair? Any questions?